Assalamualaikum, welcome to MoonBoy channel, and this is a new video for you. Do like my video so that I can create more for you by clicking on this like button, and also subscribe my channel if you haven't subscribed my channel till now, and also press on the bell icon if you're not getting this notification for my channel. You will get a notification every time I upload a new video. Thank you.
Hello, welcome to another video of ETABS, and in this tutorial we will see about time history analysis. So previous ETABS 15 video also I am having. In that I have shown you time history analysis, but at that time we were not having we have not followed completely the ETABS with the IS code. Now we have latest IS code, that is IS 1893-2016. As per this latest code, we will be doing today time history analysis, and I will also show you how to find a time history file from websites or online. So sorry for the disturbance in the background. Some prayers are going on around my flat, so sorry for that. And also I have bought a new mic, Boya M1 BYM1. In this, good noise cancellation is there, so I think most of the noise will not be captured, which are from the noisy environment. So even if some noise is coming, that is because of loud speakers around my flat, some prayers are going on, so sorry for that. So let us continue with this video, and in this video we will learn about time history analysis, as I said. So let us go to the time history. So I have already a building. In this earthquake analysis we have did already EQX, EQY and EQZ, and from that again we have did response spectrum on this. Now I'm going to do it time history analysis, and I will not run any time response spectrum function in this. So that will be totally time history function. I'll be running on that, and you should know what is the difference between time history and response spectrum. And time history is totally the dynamic analysis, and in response spectrum we have the code factors based on the code spectral curves, that is SA by G values, and the coefficient. Already the code has derived on some response spectrums, response curves based on that, and based on that time period you will be having the total response of the building. So that is response spectrum analysis. Now in time history analysis you will take earthquake data, actual earthquake data that has happened in previous years with some magnitudes, and that will be giving you how much response on your building. That you can find out, that is by PSA curves and all the results you will be finding. And for those results you can go back to my previous videos in ETABS 2015, and for the newest procedure of finding the doing the time history based on ETA, that is based on IS code 1893-2016, we have to see this video, follow this video, and do the step as I do. And also I will show you the website of ETABS knowledge base, from where you can find all the details of time history analysis and what are the steps in it, and which value you need to select, from where you have to which procedure, which method of time history you have to do, direct integration or non-iterative or iterative, all these things you have to see the options, and which option, if you select FNA case or other case, non-iterative case, which is feasible for your building, which is good for your building. You can select by reading those documents. So let us go to the website and see. Before that, let me save it as a time history analysis file. I will save it as here I will write time history method. Okay, and I have saved it as a time history method. So now what I will do is go to I can go to ETABS. Here I have the time history ETABS. Okay, so I'll give you this link in the description below of this video, and you can directly go to that link and find about time history analysis, right? So here we have the time history analysis. Okay, so these are the different time history options here we will be having. You need to read about this time history, that is floor vibration due to human footsteps, and RITs and eigenvectors. What are these? Okay, then what is time function? What is two methods? These are the two methods, that is FNA and direct integration method. These two methods, and then which is best, you can find it here. And you have the progressive collapse analysis, that also you can do using time history. And the initial condition free vibration, for free vibration you can do time history. FAQs also available here. So each and everything you want is available here. Again, I can show you another tab. In this you have like what is actually the time history analysis steps, right? So time history analysis first steps. In this, it is shown based on the program 2000. So you can follow the similar steps, and you can do the time history analysis in ETABS also. That is, you have to create a model, and you have to give the supports and joints. You have to go to the function and give the time history function. Then you have to assign the conditions of a model through assign loads. These frames. You have to give the joint loads and frame loads. Then you have to give the model and the direct integration time history method you have to give, and then you can do these options. Okay. Okay. So if you search for this time history analysis, you have here time history analysis provides you the linear and non-linear evaluation of dynamic structural response under loading, which may vary according to the specified time function. Dynamic equilibrium equations given by K and KUT, and this is the equation of dynamics. So after that are solved using the modal or direct integration methods, and FNA is nothing but the modal method, and the direct integration is the other method. So the initial conditions may be set by continuing the structural state from the end of the previous analysis, or you can give the additional notes. So step size you can give HHT, you can give non-linearity and links. These are the different things. What is FNA, what is time function, you can read out here, and all the topics are given here. Okay, based on IS 1893-2016 we will do the FNA case today in this video. So let us go to FNA. Okay, so this is a modal analysis method useful for the static and dynamic evaluation of linear or non-linear structural systems. Because of its computationally efficient formula, FNA is well suited for time history analysis and often recommended over direct integration method. So this method is often recommended. So ETABS itself, the CSI group and the structural engineers are recommending. Here you can see this is created by Mike Abel. So he is recommending that FNA is much better than the other procedures, because what are the things you are having here. Uh, During dynamic nonlinear FNA application, analytical models should be primarily linear static, have a limited number of predefined nonlinear members, and lump nonlinear behavior with link objects. So these are the things you need to be consider while doing FNA. So based on that, you will get the results. So uh, I have tried both the methods, and both the methods will give the similar results. And for getting a very light, means very less time gap, so you can go for direct integration method. It will take more time, and it will also give the accurate results. But if you want to do fast, so you should go for model analysis method of time history. So now let us find a time history analysis. Let us get the time history for the latest earthquake nearby India, that is in Nepal earthquake. So what you have to do is you have to just follow this. You have to just Google it for Nepal earthquake data. That is Nepal earthquake time history data. Yep. So Nepal earthquake time history data, if you go for it, let us go to the first. Click on that. Take the Nepal aftershock one. Take the process data. You have the dat file here. This website link, I will save it. So if you click on this, you can download it. Okay. So like this, you can save all these files available here. So I have taken the first file. Okay, open in the notepad. So here the time and acceleration has been given. Okay, this is x, y, z axis acceleration. This is the time. You can see it is line number 35, column number 1. So line number 35, column number 1 is nothing but your first time. So the time period is starting from here. So column number 5, you are starting the line, and the acceleration, this and this, these three are the acceleration, and you can give from where acceleration starts from here. Okay. So these values you can provide. Duration time 100 seconds, sampling frequency is given. So let me show you how to use this file. Okay, so you can go to define, and you can go to functions and time history function, and define a function and delete the previous functions. Select here from file, add new function, write here the time history function. Okay, then you can browse for the file. So you can see this is the time function actually has taken, but you need to give the perfect values here. And values of earthquake time intervals. So for that you have to open this in a file. So the time interval here given as 0.01, right? Header lines to skip. How many lines you need to skip? Here this is the line number 35. So line 34 lines you need to skip. 34. Now you can see this is the time history function it is becoming, but at the last it is becoming like this. So this also should not be there. So prefix characters per line to skip. Okay. Number of points is 3, and prefix character skip 20. Now you can see okay, this is the time history. So the earthquake data, should be like this. If the graph is coming like this, then it is correct. So and the number of lines, so number of points per line. Okay, so the number of points per line is nothing but how many points you are taking. Okay, so 1 point, 2 point, 3 point. This is 3 points per line. So I have set up the time history function. It has taken the time history function name here, like this only. So after that, save it, and in the next video I will show you how to give the THX load, THY load. In the previous ETABS version also, that is ETABS 2015 video also, I have shown how to give THX THY load, but at this time I will show you how the factor will change, that is the scale factor will change. First you have to take which scale factor, then only you will get the um, answer, that is answer correct, that is time history function will be correct. You have to take the g value here, and g value you have to provide as per the this units. Okay, so I'll be showing you in the next video. Until then, bye bye.